Hello, everybody, and welcome to the next episode of Tech Bites, presented by HighTechU. I am so thrilled to be with you again here today to introduce you to some really interesting, fun, and engaging tech topics for teens in these Tech Bites series. So if it's your first time attending a Tech Bites Tech Talk, I'll give you a little bit of a background on what they're all about. So just like our slide here says, or our screen here says, Tech Bites is bite-sized tech talks for teens. So this is a nice, fun, interactive way for you to learn a little bit more about some interesting tech topics and to also interact with the presenters. So today's episode is not meant to be one where you are literally just here watching. We want you to engage. So in the chat, you'll notice that there's somebody called Flight Wizard. Now, Flight Wizard's a HighTechU moderator who's there to help answer questions and guide things. So feel free to send any questions that you have Flight Wizard's way, and then I'll be able to pass on similar questions over to our presenter, who today is Venish. So please feel free to utilize the chat. It's there for you. We want to provide an opportunity for some interaction. And with that being said, I'm going to introduce today's Tech Talk. So if you are just tuning in, our Tech Talk for today is a tinkerer's introduction to breadboarding. And today's episode, while also being presented by HighTechU, is being presented by the University of Victoria's Department of Electrical and Computer Engineering. So without further ado, in just a moment, I'm going to turn it over to our main presenter for today, which is an amazing staff member named Venish, who's a graduate student here in the University of Victoria Faculty of Engineering. And I will turn it over to Venish to welcome you and talk to you a little bit more about circuit design in the world of electrical and computer engineering. So Venish, you're muted right now, but I'm just going to unmute you, and then I'm going to switch you over to that video. So just give me 1 second and I'll get that set up for you. All right, Venish, you are live.
Hello, folks. I'm Venish Patel. I'm from HighTechU. I'm an outreach support assistant for HighTechU. Today, I'll show you how you can breadboard. You can use breadboard in Tinkercad for making some amazing, cool circuits. I'm currently pursuing Master of Engineering in Applied Data Science, and today it's all gone about my favorite microcontroller, Arduino. So this is first of all, I'll give you a introduction about Tinkercad. This is a very good platform where you can build your circuits and actually implement this circuits in real breadboards or Arduino using the kit, and you can also copy and paste your code from here. So easily you can build your circuit. I will start here by creating a new circuit. From here, you can search whatever components you need for building your circuit. So first of all, I'll take the breadboard. First of all, after that, I'll give you an introduction about breadboard. So the line runnings all the way down the longest side, these are the power rails. This is because we can plug our microcontroller like Arduino or power supply into them to provide power to the components on the inside, and we connect the VCC and ground to these lines. So particularly VCC means the positive voltage, and ground means the negative voltage from the power supply. Now talking about points between these lines, between this and this lines, all these points, these are always marked horizontally in vertical manner, starting from A to J, and horizontally starting from 1, 5, 10, 15, so on goes till 60. All these 60 lines are connected vertically, and these are divided into top and bottom. This is the top part and this is the bottom part, and this is a center line in which half 5 points are joined, forming 60 contacts in the top half and 60 contacts in the bottom half. So these lines are known as component lines, and this are where we can place our components like LED, resistor, push button, etc. The next thing is to provide power to the breadboard. So we'll take the Arduino from here, from our components list, and to power the breadboard we'll connect Arduino. It's best practice to always connect 5 volt and ground to this long rails as a starting point for any Arduino circuit. Yeah, hello. Yeah, sorry about that. Now I'll show you that how you can wire Arduino to the breadboard. First of all, we'll ground it to the Arduino. This is the way how we ground the circuit, and always we should keep the color of the wire which is grounded, it is black, so we know that this is grounded. Now we will connect this to the 5 volt as I said earlier, and we'll change the color to red just for better understanding. Now we'll also do the same here. Now we will grab the other components like LED, switch and resistors which are needed for this circuit. So as I said that in this component lines we have to place our LED. We can place it anywhere from here. Now as this is a cathode and this is a anode, we have to always ground one of the component. So will cathode is a negative and anode is a positive. So we'll ground it. Now we will use the resistor. So the resistor I'll be using, it will be of 220 ohms. To provide a connection to it, I will use the pin number 13 from the Arduino. Now I'll be using the push button to operate the switch. It should be between this two halves so it can connect it. We have to also ground this and connect and also connect it to the number 2 pin. I will connect this to the number 2 pin. Now for this we have to use a resistor, and the resistor we will be using for this should be of 10,000 ohm. We can horizontally, we can move our resistor to the horizontal. Now I have to also I have connected one part of the resistor. Now I have to ground the other part of the resistor, and which should be black obviously. Now I have to also connect this part of push button, and I will keep the color of this to red just for the better understanding. Now as we have connected all the components of the circuit, we can code the circuit. We have to go here in the code. Then this is the default code, but we don't need it, so we'll garbage it and build our own code. First of all, we'll go to the control and then use the if else statements. Then now we are going to jump into inputs, and we are going to read digital pin, and we will as I showed that this these are the digital pin, so we will read the digital pin number 13. We'll also need some math for this. So we will use 13, which should be equivalent to this. So here we'll be using the digital pin, not the 13. First of all, we have to integrate the our push button. So we'll be using the digital pin number 2 here. So this is the shape that doesn't fit here. So for that, we have to add some math variables. And we have to equal this to the high input. Then we can now use this number 2 here, and then our if statement is good to merge here. Now as we have set this to the high, now for the output, we'll be using the number 13 as it is our output. We are doing this block coding. This is a very good feature of Tinkercad. And now in the else statement, I will repeat the process from the beginning. First of all, we'll use the if else statement. Then for the input, we have to input the pin number 2. So we'll be using number 2 pin. But as this part doesn't fit here, we have to use the math. And merge this here. And then we have to equals to this to the high input. Now we have to use the output, and we have to set this pin number 13. And another time we have to use it as a low in the else statement. Now you can see that we have started the simulation. This LED is blinking whenever we are pushing this button. We can also see our code. And this is the form of the block coding, and it is really simple to do. You can download your code from here, from the option download code, and then you can simulate the same circuit in real by using the Arduino and breadboard and all the components this are mentioned by using the code that you have just did by yourself by the method of block code. And when you stop the simulation, it will be again, you can render your circuit. Here you can see the text version of your code. The pin mode we entered is 2 for the input, and the pin mode 13 is for the output. Then this goes into the if else loop. So if our digital read will be high, it will blink into the circuit and it will then goes to the output, and the delay we used here is 10. So here you can see that whenever you'll press the button, the circuit will light, the LED will light, and if you push the button constantly, it will be lighted. So thank you guys. This is all from my side today, and sorry for a few disruptions. Thank you.
Awesome. Thank you so much for another great session, Venish. And if I'm right, this is your last session because next week we're going to be hearing from Matteo, correct? Awesome. I think we've lost Vinish, but yeah, so next week's session is going to be a continuation of the amazing stuff that Vinish has started with our last two Tinkerers Introductions 2 sessions. So please tune in again, same time next week for the next in our series presented by the Department of Electrical and Computer Engineering here at the University of Victoria. So on behalf of everybody here at HighTechU, on behalf of all of the sponsors and funders, Coast Capital Savings, University of Victoria Faculty of Engineering, all of our other amazing community supporters, thank you so much for checking out the session. If you're interested in learning more about what's going on here at HighTechU, Flight Wizard just put into the chat about our Twitter channel, so definitely check out our Twitter for latest updates. Head on over to hightechu.ca for more information on that. Please follow us on Twitter, follow us on Instagram, like us on all of the platforms, like us on Facebook. Check out our Tech Bytes ECE episodes. The link is in the chat. And if you're interested in checking out more of these sessions, if you're here on Twitch, you can head over to YouTube. And if you're here on YouTube, you can check out our playlist, both our Q&A quarter playlists, which are our sessions that we do, which are interviews, and then also the other dozen versions of our Tech Byte series. So with all that said, again, Vinish, thank you so much. Flight Wizard, thanks so much for being here in the chat. And to everybody out there, thank you so much for being here with us today. Stay safe, stay healthy, and we look forward to seeing you on the next episode of Tech Bytes. Bye.